What I want to do is look at the limit of a polynomial over a polynomial. So here's an example of a polynomial over a polynomial. A polynomial is just whole numbered positive powers of x. And these kinds of limits come up. We'll see more of them in the next chapter. So what I'm going to do is establish a rule, and it's a rule that you can use on any test, quiz, whatever. If you look at one of these and you see that the top has higher degree than the bottom, n bigger than m, you can just say the limit's infinity. If, on the other hand, the bottom has the biggest power, so n is smaller, you can say it's 0. And if the powers are the same, then you can say it's an over bm. Now, I know this is a lot of notation. It's not that bad. It's just a way of cataloging the terms. This subscript here has to match the exponent. So that's just the coefficient of the nth degree term. So here's an example. Here's our limit. We have n is equal to m, and I'm going to say that our answer should be 7, 6. So basically, here's a3, that's 7, coefficient of the third degree term. a2, that's equal to 3. That's the coefficient of the square term. a1 is minus 8. And then a0, there's no coefficient for the constant term, so that's 0. b3 is 6. b1 is 2. b0 is minus 52. And then b2, the coefficient of the square term, is 0. So that's all this is trying to say. And it's notation that we'll use later. So I want to show you that this is 7, 6. So clearly this limits of the form infinity over infinity, because of the higher degrees terms dominate. So this limit, I'm going to use L'Hopital once, and I'm going to get 3 times 7x squared. I'm going to get 2 times 3x to the 1. I'm going to get a minus. I'm going to get a 1 times minus 8x to the 0 here. And then here I'm going to get a 3 times 6x squared. Here I'm going to get a plus 1 times 2x to the 0. And again, here I'm going to get a 0. Okay, I plug in, that's still infinity over infinity. So I'm going to use L'Hopital again. Bring the exponent down, I get 3 times 2, 7x to the 1. Bring the exponent down, I get 2 times 1, 3x to the 0. That's a constant, so that's going to be 0. Same thing, 3 times 2, 6x to the 1. Constant terms, I'm going to get a 0 here. I'm going to do this one more time just to show you that it cancels, so probably we don't need to. This is still infinity over infinity, because I have powers of x. So I use L'Hopital one more time. I bring the 1 down, and I get 3 times 2 times 1 times 7. This is 0 over 3 times 2. Put the x to the 0 in there, times 1. 6x to the 0. These factorials cancel out, and I'm left with 7, 6, which is a3 over b3, as claimed. Okay. So you can imagine, no matter what power this is, we just use L'Hopital enough times that all these terms are going to go away. We're going to get a situation like this, n factorial over n factorial. These cancel, and we're just left with these coefficients, just as we are here. Okay, and again, you can just say this on a test. So I'm going to do one more of these. I'm going to do this one right here. So I'm just going to make up an example. Lim x goes to infinity. We want the top one to be better, so 4x cubed plus 2x plus 10 to the 10. The bottom, we're going to have m is going to be less, so let's say it's 2, so I'm going to have 5x squared minus 8x plus 10 to the 1,000. So really big numbers there. Okay. So this is clearly infinity over infinity. The highest term brings both to infinity. The graphs of the polynomial go off to infinity. So I'm going to use L'Hopital. Again, what I'm claiming is I'm going to get infinity. You can see why. That there's still going to be exponents left here where there won't be any here. So, but we'll go through it. So we get 3 times 4x squared plus 2, and that 10 to the 10, which looked so powerful, is gone, right? Derivative of the constant is 0. Here we get 2, 5 times x, and then we get minus 1 times 8x0. This constant also goes to 0 when you take the derivative because it's a constant. So take one more L'Hopital. I still get infinity over infinity because of the polynomials. The graphs go off to infinity at the top, then the graph at the bottom does. So I go one more, I get 3 times 2, 4 times x, 0. Here I get 2 times 1 x, I'm sorry, to the 0. So this is going to be, the top is infinity, the bottom is 2, so I get infinity. So the same thing is going to happen here. Eventually, we're going to run out of powers of x. We're going to get to a constant. There's still going to be a power of x here. That's infinity. And in this case here, it's the opposite that happens. All these x's are going to go away till you get a constant, and you'll still have powers of x here. You'll get 1 over infinity. So the point, you can say, since n is greater than m, the limit is infinity. It's good to say what is, since n, which is 3. Okay. And let's say another example. Let's say this is an exam question. You have this limit. X goes to infinity. X to the 99 minus 32. X to the 50 plus 5. This is x to the 101 times 10 plus 100 times x to the 99 plus 15. Now, you could use L'Hopital 3 times, or you'd say n is equal to 99. That's less than m equals 101, since the bottom polynomial has a higher degree. The limit is equal to 0. Again, it just makes it much quicker. So I hope this is helpful. Thank you.